Hello and welcome back to making a synthesizer in C. This is episode 7. This will be a quick episode, I think, but let me go to my phone. Here we are, episode 7. So last time we added MIDI keyboard input. Let me show you that. So here's our little synth. So we can add, set a few things, and here we go. We've got MIDI keyboard input, which is pretty cool. And the cool thing is my MIDI keyboard has an arpeggiator, so I can do things like, which is pretty cool. Yeah, so at the moment it's monophonic, so I can only play one note at a time. So let's have a go at making this monophonic. Alright, so just before the stream I did change a few things. So I've added this file called synth platform. Hang on, that's not file. Here we go. Synth platform. So this is just where I'm setting all my aliases for the different types. So this is just in preparation to make the synthesizer more platform independent. So when you see things here like I8 or I16, that's a signed integer with 16 bits. My U32 is an unsigned integer with 32 bits. F32 is a float with 32 bits, etc. Things like, so one of the annoying things in the language of C is it has this keyword static, and it means different things depending on where you define it. It's got 3 different meanings. So a common thing people do is just define it to another keyword. In this case, global for when I'm using it for like a global variable, local static for when it's like a locally persisting variable within a function, and internal for a function that you can only call from within the same linkage or within the same file, basically. And just some other utility functions can live in here. I've put the log function here, and I've added some random number generating functions here. Cool. So let's come back to the synth. And let me just check my, audio is looking good. Right, so we want to add in, if we come to our draw UI function here, and it was further down here where we're actually resetting the synth and then we're getting the MIDI keys. So we want to do polyphonic. I'm not a fan now of doing all this within the draw function. Like, this is the drawing, and then really this doesn't belong to drawing now that we're actually moving the data from the UI into the audio oscillators. So what I'm going to do is just go ahead and too much. Cut that. Let me move my MIDI keyboard to one side. I don't need it for now. Okay, and what we'll do is we'll put this into another function here. I'll call this ApplyUiState, and it's going to take in our synth, and we'll paste that in there. So that should still work if we come down to where we draw the UI, and then we'll do apply synth state. That's gonna. So let's make sure that still works. Yep, still works. It's annoying having to set these parameters every time, so I'm gonna set up default parameters. So if we come up to where we click the button to add a new oscillator, we're gonna set defaults here. So let's see, let's just set the default. I'm going to need the UI oscillator. Call this UI osc, and that is equal to a synth UI oscillators. Is it? Yeah, oscillator plus synth UI oscillator count -1. And so the default oscillator shape, I'm just going to give that, give it a sine shape. The default frequency is just going to be, what is it called again? Synth bass note frequency. And the default amplitude. Oh yeah, I've changed the name of this variable to amplitude ratio. I'm using the term ratio for numbers that are usually between 0 and 1, where 1 is the full value, 0 is like no, but it can still go over 1. Like a value of 2 would be 2 times the full volume. So yeah, I'm just using that as a convention now. Let's say 0.1. Because don't forget, it's this ratio would then get converted to decibels. And then the shape parameter. We'll set that to half. So let's give this a go. Here we go. Now that works out the box. Full volume. So at full volume, we need to not draw it so big, I think. So here where we're drawing the signal, I'm gonna go ahead and put this at 300 maybe. That's better. At some point we'll probably have to pull this out. Let's do that now. This can all go in a different function. So we're going to have a draw, call this the draw signal, pass it the synth. We'll do this above the internal void, draw signals. Yeah, I need to remember to keep some of this consistent, where the pointer goes on the variable name like the type. So we'll paste that in. That should in theory work. We'll just check if that doesn't. No. Structure union. Right, so all these now need to change to we're drawing the fundamental frequency. That kind of information can go back into the main. Yeah. Very good. Still works. All right. So, so I'm going to tag these functions draw So these are just comment tags that they're pretty handy. I'll show you what I use these for. I'll call this a draw FN for draw function. So if I come over to this other panel here and I open, what I can do is I can search for draw FN, and I'll just go ahead. Sorry, no. And sorry, it'll go ahead and find all those functions that I've tagged with this draw FN function and put them into this panel, which is pretty cool if I'm just needing to jump around the code base. And I like to save this to a slot. So I've got like all the MIDI structures saved to one slot. Now I've got like my draw functions, stuff like that. So it's just a little helper for moving around the code base. But for now, let me just go back to the scratch. Okay. So we need to handle multiple notes. So we've already got that information in our MIDI keys structure. So I think this is where my intuition of creating a separate structure for both the oscillator that does the actual audio generation and the UI oscillator, even though like if you look at them, they've got a lot of shared data. They've got frequency and amplitude. And you might think, oh, well, that was a waste of time just having to copy data from this to this. But actually, now that I've got these two separate concepts, it makes it really easy for me to implement polyphony, because come back to my no, it was called apply now. ApplyUiState. I can make multiple actual oscillators for each UI oscillator, which is what you want to do if you're holding down different notes. So here's how I'm going to do that. I'm going to say for so we're going to move this loop into here. We are still going to do it backwards. MIDI keys that count. -1. So then what we want to do is I'm just going to get that note. So that will be MIDI keys, data, note, index. So that's called a MIDI message. We'll just copy that. Make sure that's the right. Oh no, sorry, it's called a MIDI key. And then what we can just say is if the MIDI key is equal to 0, or I'll just do like, we will continue. So we'll skip this iteration of the loop and go to the next one. And then we're going to get the oscillator. Where is OSC actually defined? Here. So this actually now needs to come into this. Yep. And then if we did actually get the oscillator, so at the moment we are ignoring the frequency slider we set in the UI. It'd be cool if we can actually use that as like the base frequency and then the note we play. Yeah, so if it's set at our base frequency, which is 440, then it should all just play normal But if you were to double the bass frequency in the UI and you were to play a note on the keyboard, it would play an octave higher. I think I'll do that. So to do that, we're going to have to get the UI semitone. So that's going to be a semitone from frequency. So that's going to be UI os. You know, at this point, we don't need to get a pointer to it because we're not actually changing. There we go. So we can get the frequency, and then what did we have here? Frequency from semitone. Semitone equals. So we need this. So I'll call that the MIDI semitone. That's all right. So that was doing the MIDI key. So that's just the MIDI key note minus the bass MIDI note. And then we finally want the actual frequency, which is the note. The oscillator frequency would be frequency from semitone, and we want the UI semitone plus the MIDI semitone. Well, actually, we want the bass semitone, which would be semitone from. Actually, no, that's all right, because our MIDI key note is already relative to the bass MIDI note, which was A4. So if we play, yeah, I think that's right. And then we just set osc. That's the oscillator. So that means we can now get rid of all this, right? What's it complaining about? All right, let's give this a go. Let me make this a little louder. So now I can play chords. Cool. And then if I change so that means I can do a little bit of interesting detune, where if I can get this back to 440. So it's pretty small to see, the font size is pretty small, but this is at 443 Hertz and the second oscillator is at 440 Hertz. So they're off by 3 Hertz, and you get this. So that sounds really cool. And then if I do an arpeggiator, well. So let's go to town. And just add, you know, set in a triangle. Let's make this like 220, maybe, if we can. Let's bump, add in a rounded square. We might have to This is pretty fun. It's very, and it's even more satisfying when you know that you've made this. Okay, enough playing around. Let me put my MIDI keyboard back. So, we've added polyphony. It's pretty good. What next? Oh, yep, we can get rid of that line. LFO. What time is it? Yeah, I did say this would be a short episode. I don't have much time today, so I'm gonna call it quits there. But next time, yes, definitely, we're going to start adding in frequency modulation, you know, amplitude modulation. Yeah, I'm going to do pulse width modulation, all kinds of modulation. For our next episode, which will be episode 8. Until then, see you next time. Bye.